Okay, guys, let's go. Methods and program decomposition. Tell me, please, how many lines have you had at the most long program in our projects now? So maybe in project 4, the last task, how many lines have you had in that method? In your projects? Just not in your life, but just about university. 130, okay, and who else? How much? 100? 160? 101? Okay. 120? 285? 85. Okay. So, why I'm asking? Of course, there is no such rules, despite that some very prominent people trying to even share that there is some restrictions of maybe 40 lines of code for one method, for one function or less. Of course, there is no strict requirement on number of lines in your code, but to have 200 of lines in your one program, just have this very long list of code, it becomes complicated for other people when they open your code and trying to understand that. Because you should remember that you write in the code not only for machine, but you also write the code for whom? For your team, for your colleagues, for possible team who will continue with this project when you switch to another project, for example. You transfer your project to another hands, let's say, and they will somehow, they should understand that. And to have this long logic with 100 of lines, maybe not the best way how to write a program. That's why we have this beautiful opportunity to build methods. And we will talk today about methods and how to use methods to decompose the program. What that means? That, first of all, means that complex tasks could be made breakdown. So we have some complex task. I want to go somewhere and do something or solve some huge complex problem. What will I do? I have this huge task, and to save myself from any procrastination, what should I do? I should break that task into smaller tasks. And then it becomes solvable, because this huge task is so complex, how to understand, how to solve it. But when you break that task into smaller one, oh, this quite easy to solve, this quite easy to solve, this quite easy. And you make this several steps, but you solve complex problem. The same way we could do that in programming. So you see here this example, like when you structure your stuff. I heard, I tried to even find maybe some interesting video in regard to this problem, and I find some comic, and he just explained that all our life is about how to bring and store our stuff. That was really funny, but with some bad words. That's why I didn't decided not to use that. But that's really interesting. But our stuff, which we have in our life, we not just put somewhere in the middle of the room and live in such a way. Maybe someone does, but not the best way to live. We're trying to make some order in our room, in our desktop, even in our computer, to put into proper folders. So we're trying to organize, we're trying to make some hierarchy. So I have some message. Yes, divide and conquer, exactly. So we're trying to really divide, to split some complex and to bring order. The same thing we have to do with programs which we write. And this concept is really related to structured programming. So we have this paradigm. You will hear this word more and more when you learn programming. Paradigm. One more hard word. Decomposition. Paradigm. iteration. Yeah, so paradigm. What is that? This is some mindset how you create, or some approach, not philosophical, but really conceptual approach about programming. And basically, we're just talking about ideas which was invented in, you see, 1960s, quite old. And one of representatives of that approach is Dijkstra. And you will find a lot of algorithms written by this prominent scientist, Dijkstra. And all that if-else structures, it is also influenced by Dijkstra. Because before that, we had this command, which you should, like in that movie, you didn't see anything. You remember that it is hard to explain for me in English. So you should see that and just forget. Never use Go-to. It was awful mess when we had Go-to. I basically, when I started learning programming, that was basic programming language, not that Microsoft Visual Basic, but another one, more previous. And we actually had this Go-to command, and we had lines, and I could just put the Go-to line number 2. And in such a way, you could write pretty anything with Go-to, not with if-else, which is logical, but we just go to somewhere. And but at some point, it becomes so huge mess that Dijkstra proposed that we should structure that. We should abandon this Go-to approach, which we should use if, else, for, while, all this stuff. But not only that, we should also decompose our programs. Like we have this program, we decompose that program into these 2 nodes, and every off node we could also decompose. We create modules, and we, like someone said in the chat, divide and conquer. We decompose complex tasks into smaller ones and make everything hierarchical and understandable. Let me share this. For example, let's combine that into just 3 principles of structured programming. So first of all, why it is so important? Because we have top-down design and modularity. So when you have this 200 of lines of code, it is really hard to extend this program, to maybe make some adjustments to this program, to add something, because you just add and add and add code, and it becomes very complex and hard to understand. But when you have top-down design modularity, you just create high-level modules. Then you take one module, this black box, and you go to another place and just concentrate your attention on just this one module. And maybe this one module could have smaller modules. You take smaller modules and concentrate your attention on that smaller modules, and all of that kind of independent. You could test it separately, create algorithms separately, but then we will combine that in the very large complex task. So the program is broken down into smaller manageable functions or modules. This is called decomposition. Each module or function should handle a specific task or part of the problem. Code is organized into independent functions or modules that can be reused, reducing code duplication. Guys, at this level of your knowledge of programming, you should remember that duplication is an awful thing. Duplication, it is something's forbidden. If you see that you write the same pattern of the code in different places, you should ask yourself, can I put that code into one place and just call the same code several times, not to duplicate that? But I will make one step aside and say that in real software engineering, sometimes we need to duplicate, and that will make our life easy. So I don't want you to be very canonical, but on this level, when we're talking about structural programming problems, yes, duplication is bad things. We need to avoid that. and we could test that independently. Then this leads to better maintainability and readability, since change in one part of the program are less likely to impact other parts. So if I have this hard, complex task, split it to smaller ones, if I need to make change somewhere here, there is big chance that I will not broke other parts if I keep interface of intercommunication with this model the same. In this black box, I could change anything, it will work. But if I have just one piece of code, then it is really scary to make change, because it is, you could just broke all the program. This is the idea. I will back in a moment into that example. But second, encapsulation, one more programming word, encapsulation. When you encapsulate some logic into one module, and again, you consider that module as a black box, you abstract it, you don't consider, oh, this model is created by these inner parts, very complex. No, this is just black box. You don't need to know anything about that module. What that means? Functions encapsulate their task, hiding, one more word. Of course, it is quite popular word, but in information systems, it is so important word, information hiding. Hiding details of implementation and exposing only necessary interfaces. Now, to make it simple, look to this engineering stuff here. What do we have here? This is interface, how we use electricity. But this is our black box exposed. Oh, this is some wires, and we need to connect that in that way. And this is plus, this is phase, this is that, this is that complexity of this engineering systems. But we never have this kind of sockets, right? Because we don't need to know this complexity. What do we need? We need only one thing. We need the interface. This is socket. We need just the interface. We call it interface. You know this word interface? This is not only user interface, but electricity interface, how we integrate two systems. This is interface of integration. We know this, only this simple part, but that black box behind that, we're not interested in that. Because all this engineering stuff is hidden. This is information hiding. We hide this information and just use the interface. This is our aim. When we decompose something, we need to hide from outer world that complex engineering stuff and expose only the interface. Make sense? This is engineering approach, and we use this approach in programming very, very boldly. And then use of control structures like if, else, for, while, without, go to. This is structured programming principles. Okay. Now, rectangle example. Get rectangle parameters and calculate its area and perimeter. So this is kind of, you don't need to implement it by yourself, but just consider that programming task. We get this programming task, rectangle. Everyone knows what is rectangle. We need to get from user parameters. Which parameters will we get? Width and length, exactly. Then we calculate area and perimeter. Let's try to explain, make a pseudocode of this example. First, get rectangle length, user input. Second, get rectangle width. Third, calculate area. Fourth, print area. Calculate perimeter, print perimeter. Now, let me show the straightforward code without decomposition, without information hiding, without structuring. we created some scanner. What is scanner? How scanner related to this pseudocode? Do you have scanner somewhere here? No. This is complexity of this task, how to get rectangle length. This is some additional black box steps which we need to implement. Okay. Then output system out println enter the length of the rectangle. Okay, that understandable. Then we create variable length, scanner, and so on and so forth. And for example, what do we have? We have this repeatable code, this repeatable code, this kind of strange code, scanner, what that mean? And compare this code with this code. This is also the program, a bit less lines. And what do we have here? Get user input. Next, get user input with another title. Put that into variable width. Next, calculate area with these parameters, length and width. Then just print without any system out println complexity. Print and output. What do we want to print? Then calculate perimeter. Calculate, like just run this part of the program with parameters and again. So pay attention to this code and to our pseudocode. It's almost the same. So we created abstracted steps which we need to perform to gain our A, and we basically write that steps here without any complexity. We didn't just put this, but we broke our task into smaller ones, call that with abstract names, and combine that into one flow. So these custom commands are called methods. This is topic of our conversation, how to create that methods. Let's move on. This is second part of this program. So this is basically one file. This is first part, and this is next part. So a little bit below our previous code here, we have these three methods. Four methods. 1, 2, 3, 4. And then we close this curly bracket. Let me remind you. We have this class. We open this bracket here. Then we have method main. Very concise, very logical, very beautiful. Then we have 4 additional methods, and only then we just close these curly brackets in regard to this decomposition class. Okay, this is syntax. Then pay attention. Get user input. What that means? This is it. Get user input. Some weird code here, some weird parameter here. And this black box scanner is here. System out println is here. So all that kind of complexity hidden from this beautiful main method. This is our interface. Let me come back here. This is our interface, how to use electricity. But all this inner stuff is hidden here in this method. This is how it works. Let me explain you basically method syntax. But do you understand the idea? Then when compiler, then when program, Java runtime environment, run this main method, how it works? It go to this line, it create variable, then it meets name of the method. Then what? I come to this main method. I come to this point. I find method get user input. Then I searching for get user input in my program. I found it here. So I jump into that get user method. I run all these lines and I come back here. Then I read next line. If I have another method, then I search this method, run this method and come back. Do you see the idea? Okay, understandable? Questions? Feel free to ask questions, to interrupt me, no problem. So syntax, how we do that? How we do that methods? How we do that pieces of functionality in our program to decompose our program? Let's go. First, access modifier and maybe static modifier, then return type, then method name, then possible parameters. Parameters divided, splitted by comma. But when we explain one parameter, this is type of parameter, kind of variable, declaration of variable, and parameter name. So what main terms do we have in methods? First, or zero. We call all of that. We call this first line of the method, this first line of the method, this first line of the method, and this first line of the method, and even this first line of the method, we call it signature. One more term. Of course, signature in English, what that means, signature? Ukrainian. Yeah, but you know how to translate signature into Ukrainian in programming? Signatura. Yeah, easy translation, okay. So this is signatura method. Signature, this is a specific term. So signature help us and help compiler to find specific method, because every method has unique signature. No method could have the same signature, because that kind of duplication and like this is identification of the method, its signature. Okay, signature consists of, and not only signature, but method consists of method name, access modifier, like public static. You see here, public static, this is part of the method. Parameters, return type. I will explain what that means, because method could return something. Method body, like loop body, method body, like this is some lines which we want to execute inside the method. And again, return statement, which could return the value. Okay, let me explain several methods which we have in this program, which I just presented. Method name. So for example, get user input. This is name of the method. And by the way, we didn't call this method ABC, okay? Or just method X. We use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 symbols. Wow, how hard to type all of that. But everyone who come to my program and read that will understand what that method means, right? When we name the book, you call the book somehow. You don't call it book number 7. Method 1, method 3. Please, as with variables, call the method with good logical names. This method have name print. This method has name calculate area. Everyone could understand what the task of that method. Second, access modifier and static if needed. Okay, to make it easier, at this point, all of our methods will be public static. To fully explain that concepts, I should explain you object-oriented programming, which will be later. So in Java, we should use object-oriented programming from the very beginning, but to explain that it becomes more complicated at this point, so just use public static. Public means that everyone could access that. Static means that hard words, like you don't need to create object in which this method is placed. You just could run it without that creation. Get it at this moment. Number 3, parameters, type and name. So for example, get user input. We have these parameters. What do you think? What essence, what the idea, what meaning of that parameter?
user, the method must accept a string from the user.
Pass value to the
Other ideas? Yeah, so this is the message for whom? For user. So we want to ask user to input something, but we want to explain user what do we want to input. So we put this parameter here. We call it prompt to user to input something. This is the idea. What the data type of this parameter? String, so obvious. So you see how it works. Okay, here, what the meaning of this parameter? By the way, out, it is something weird. So output should be here, placed here. This is example of bad naming. So what the essence of this parameter? What do you think? What the meaning? Yeah, so we print this message, yeah? So this is the message to print. We could call this parameter message, for example, and put this message into system out println. So yeah, this is also like message to user. Okay, calculate area. How many parameters do we have here? 2 parameters because we have comma here and here 2 parameters. What type of that parameters? So numeric, double, right? We have double here, double here. So 2 double parameters, right? Length and width. So everyone understands what is that. Okay, we get that parameters, then we calculate area and return that. We will take like number 4, return type. Return type. Okay, return type. Let's start from the very first method. So here, guys, double is return type of this user of this method. Here, return type is void. Void means nothing. Nothing. This method returns nothing. So we don't need to accept any result of this method. But for these 2 methods, we need to get some value from that methods. And we call it return type and return value. So a question to you. Why do you think get user input has result of type double? We want to have number, yeah? Why?
So we can the other method to calculate.
Yeah, because we want to get in this program width and length of type double. That's why we create return value of double. Exactly. So for example, then calculate area should calculate area and return what? What do we want to get from that method? Area. Double value of basically area. Yeah, so this is double value. That's why return value of calculate area is double. Okay, then method body. 3 lines of code of this method body. 1 line of code of this method body. 1 line of code of this method body. Then return statement. If not, void. So for example, void, we do not want to return anything, so we have no return. You see here return, see here return, but here we have no any return value. Okay, so if method have return type of double, then we return basically double. We get double from the scanner and just return that into our main program. In this variant, we calculate length, multiply width, and return value of that into our main program. So let me come back to my program. Here, for example, I call method get user input and take this return value and put this return value in this length. Run get user input, scanner, create scanner, then output println prompt, message to user, get user input. double value. Take this double value, put that into return, get this return value, and put this return value into lens. Do you understand that? Make sense? Questions? You should try that. You just should try it. Okay. Yes. One more interesting concept, method overloading. The idea is that we could have basically methods with the same name, but different signature. Name is the same, but parameters is different. That's why when we call this method, Java check what kind of parameters do we have, and then decide, oh, okay, programmer want to call this method or this method. So for example, we want to optimize and not to create many scanners. So we create scanner in the main method, and then we just call get user input, and not only put message here, but also put scanner here. So compiler having two methods will choose, oh, I need two parameters method. And that's why compiler will choose, oh, this is this version of get user input. So overloading this basically good example of flexibility and polymorphism, one more term in programming. Okay, guys, I want you to now to try that. I want you to try. So let's come back to our huge 100 lines of code and try to decompose that into method. So you could even substitute some user input, as you saw in this my example, but try to break your project into methods and combine that somewhere. So this is your task, and we will check it. Okay. So again, choose one version of three of you, for example, and just work all together. 3 people in the team, not more than 3, and just work on that.